there's a couple of people that are not familiar with is something called summation notation. Now, exponents give us repeated multiplications of the same base. Factorials give us repeated multiplications of a descending base, if you will. What we now would like to do is introduce a notation that will give us multiple additions. And that's going to be in our next thing, which is summation notation. Say, for example, I have to add 2 to itself, say, 10 times. And I have to write 2 plus 2. And it would be a cumbersome thing. It's 5, 6, 7, 8, 9, 10 times. That's an awful lot of additions to have to write each time. Is there a notation we can use to kind of condense that? That's going to be the summation notation. And what we're going to do is we're going to use the capital Greek letter sigma. And it looks like that. That's sigma. And we use sigma because it has the S, and the S in sigma means to sum. Okay, so I'm going to sum, in this case, up above here, I'm going to put that particular example in. I'm going to sum the number 2. Well, now what do I have to do? Well, I have to, in some way, like an exponent, how many times am I summing? An exponent, we know how many times we're multiplying. How do we do the summation? Well, what we do is we introduce a summation index, and we're going to use this notation here. This is our index, I for index, and we're going to say I equals 1 up to 10. So you count. So what does that mean? I is equal to 1, I start out with, and there's 2. Then I go I is equal to 2, I do plus 2. Sum means to sum. And I keep carrying that out just like I have up there 10 times. And that's our summation notation. Now, the I can also be quite useful because you can actually change this number. That's if we just have a constant number. What if I want to put something in there that's going to be changing, like a factorial changes all the time? How can we do that? Okay, so that's our definition of what a summation notation looks like. You're going to have your summation and your index, what you're summing from and summing to, and what is under the summation symbol there. What comes after it is how you change it. Let's take a look at another different type. This is where they get so many different types of summations. Let's put a more complicated example. Now, well, I'll choose something for that I. I'm going to hold off on the blue. The blue doesn't seem to want to go away as readily. Well, let's consider this sort of problem. Well, let me just say up front, there's 2 types of problems. There's 2 types of problems that we're going to consider here for now. Later on, you'll look at other things when you get to calculus. The first one is given a summation, write out all the terms and sum them. So execute it. Then the other type is given a set of summed terms, write in summation notation. Now I should point out that this will not always give you a unique solution. Let me just mention, kind of put that in there. Little disclaimer. This is not always unique. Meaning, I can write it in 2 or 3 different ways, or really infinitely many different ways, and get the same result. So it's not always a unique solution. So people could give me different answers on the test, and they could both be totally correct. And there's no preference for one or the other. Okay, so let's start with the first over here. This is getting used to the summation notation. So let's take some examples of that. You saw the first one with 2. What if I do this one now? I'm going to just sum I equals 1 to say 4 of I. Now the I is placed there. So what does that mean? Well, it means I start, plug in I is equal to 1, then I'm going to add. Sum means to add. Now I has now upped its value to 2, so now it becomes 1 plus 2. Then I up I to 3, and I sum it. And I up I to 4, and I sum it. So this is shorthand notation for taking 1, 2, 3, and 4 and adding them together. And you can see over there you just get 10. So that's the final solution to that. Okay, take a look at another one. Sum I equals 1 to, say, 5 of 2I minus 1. Now, this is all under the summation here. -1 is not outside. It could be. Sometimes you do calculations and you have to know what's under the summation symbol. Try that. Tell me what you get. So write it out, and then we'll add everything together. This is also good because it also shows you something of how to write certain types of numbers. And anyone want to see how I got that? Is that okay? So let's plug it in and see what we get. So we start putting I is equal to 1. So we start with I equals to 1. 2 times 1 is 2, minus 1 is 1. Then we move to, and we're summing, and we move now to I is equal to 2. 2 times 2 is 4. 4 minus 1 is 3. And then move to I equal to 3. So 2 times 3 is 6. 6 minus 1 is 5. I move from I is equal to 4. 2 times 4 is 8. 8 minus 1 is 7. Then I move to I equal to 5. So it's plus. 2 times 5 is 10. 10 minus 1 is 9. So at each stage, I put in the I value, and I figure out what that quantity is, and then I sum it to the next one. When I hit 5, I stop. That's the ending point. So that's all that notation is. Notice this is an odd number. I'm saying sum the first 5 odd numbers. Okay. Now, as we're doing this, kind of start thinking of process 2. Process 2 starts with this and ends with that. So type problems, type of 1 goes from, these are all the type 1 problems, from here to here. Type 2, we start with something like this, and we end with the summation notation. That can tend to be a little bit more difficult. Okay, let's put in a couple more over here and see if you can do that. Let me give you some to try and see how well you can do. So try some of these type 1 problems. All right, that one. I equals 0. I don't have to start out at 1. I can start out at a 0 value to 4 of pi. throwing off factorial in there too. So see if you can write them out long form and then write out their final value. Okay. Everyone see how to do that? Not too bad. Everyone comfortable working those sort of problems there? Okay. Try one more and see how you do on this one. I'll give a couple more to see if you get confused or not. So there's one, a couple more. I'm not going to write it out this time. I'll just put the final answer. I'll do it in my head, so I may make a mistake, but we'll check it just in case. When there's nothing there, it's by default, there is a 1 here. So when you don't see anything, it's not 0, it is 1. Let's see if you can work those two out and see what you get. This is 2 raised to the I, right? It's 2 to the I. Okay, does anyone want to see problem 4 worked out? Someone getting -6 out of that? Okay, so that's okay. That's good, too. What about problem 5? Everyone see that? So anytime you start from 1 and you go up to a final number, it's always that. Now, if I change it slightly and gave you this sort of problem instead, I equal 2 to 8 of the same thing, that would have only been 7 additions. So that would have given me the number 7. Just notice there's no I. So I start, take 1, and I add it to itself. I is equal to 2, 3, 4, 5, 6, 7, 8, which is actually 7 times. Okay, so that's our summation notation, going from a summation notation and writing everything out. Nothing more than -2 plus 4 subtracting 6. Subtracting 8, excuse me. And then you just add everything together and you get -6. Okay, so that's type 1 type problems. Let's see if we can figure out these type 2 problems. Now, instead of given the summation, we're given a sums of numbers. For example, I'll give you an easy one first. So I'm summing the first, in this case, 6 odd numbers. How would I write that? Okay. I'm going to start by writing my summation. Now, I has to, in some way, give me 6 different numbers. Now, I don't have to start at 1. I don't have to start at any particular number. For this one, I'm just going to pick one. I could start at 0 too, and I'll show you the same thing. Like I said last time, this is not necessarily unique. You can have many different forms of this that'll actually give you that same result. But for this one, let's start I equal to 1. And since there are 6 numbers, I have to have 6 summations there. Notice these are odd numbers. Well, how could I write an odd number? Well, I could write it as 2 times I subtracting 1. Put in I is equal to 1. 2 minus 1 is 1. Put in I is equal to 2. I get 4 minus 1 is 3, etc. So that's how I would write this. Now I could write it in this other way. Here's an alternative way of writing it. Like I say, it's not necessarily unique. Both of these are perfectly acceptable. I'm going up to 5. I could write it as 2 times I plus 1. So I'll start it with I is equal to 0. 2 times 0 is 0. 0 plus 1 is 1. Now put I is equal to 1. 2 times 1 is 2. 2 plus 1 is 3. Now put I is equal to 2. And what do I get? 4 plus 1 is 5. 3, I get 6, 1 is 7. 4, I get 8 plus 1 is 9. And 5, I get 10 plus 1, or 11. So notice, it doesn't have to be identical. So there can be many ways of writing a type 2 problem. And for me, I can look at it and see if it's equivalent. And you can test yourself out. Okay, so given that, I'm going to give you something very similar and see if you can kind of work this one out. So try this one. I'll make it similar, but see if you can see a difference over there. This one might be a little bit harder for some of you. Can you write that using summation notation? So try to write that. And again, it may not be unique. I'm going to start with I is equal to 1. You don't have to, but I'm going to choose 1. And again, I say I have 6 of those, so I'm going to go up to 6. I need to get my number right, and then I need to get the sign right. So that'll give me a plus, then a minus, then a plus, then a minus, etc. Go back and forth. I plus 1. I is equal to 0. I get -1 squared is 1. I is equal to 2, I get I negative 1 cubed is negative 1, etc. So that's all it is. This is harder. This is definitely harder to do, to see that pattern as you're writing it. Yes, Ashley, have a question?
Yes, I'm trying to flip my brain like backwards to see. I see what you did now that you did it, but I couldn't come up with that on my own. Is there like tricks that you've seen over the years where I guess like 2i minus 1, is that always going to be like odd numbers? When you see an odd number, you're always going to start with that.
You could write an odd number in 2 different ways. 2i minus 1 or 2i plus 1. Okay, so these are always representations of odds. It depends upon where you start, what odd number it starts at. For example, if I use this and started with I is equal to 1, then I'd be starting at 3 instead of 1. This would give me 3, 5, 7, 9. But when I start at 0, then it gives me 1, 3, 5, 7, 9. So these are representations of odd numbers. This is how I write the changing my sign back and forth, plus and minus, plus and minus. This starts out as a plus. But if I write it this way, with just an I, then that would have been a minus, and then a plus, a minus, and then a plus, a minus, and then a plus. If I just have an I there. So you're usually going to see I and I plus 1. You might actually also see, in a similar vein, you could, instead of this, you could also see minus 1 to the I minus 1. And if I put 1 in for I get 1 minus 1 is 0. Negative 1 to the 0th power will give me plus 1. So that's why I said this is not unique. I also could have written this in this way. And I could have put minus 1 raised to the I minus 1. It would have given me the same exact result. So there's multiple ways of writing these. So with that being said, see if you can figure this one out. These are harder. These are definitely harder, and they're more challenging. Can you write a summation for that one? So try this, and here's another one that I'll give you. I'll give you 2 more. So see if you can come up with a summation notation for each of those 3 different sums. I'll start at 1. You don't have to, but I'll start at 1. Sometimes I'll start at 0. Sometimes I'll start at 1. That's just 1, not unique. I could have put a plus 1 up there. Oh, keep me awake. Let me do it this way. I was thinking of the other one. Keep me awake. That's one way of writing it. No, keep me awake. Keep me awake over here. I just want this to be I minus I to the 1 minus I. That's what I want. One. That's what I want. Minus 1. I could go from 0 if I want. That's I to the negative 1. But it can be a little bit challenging there. Yeah. And let's take a look at this one over here. You can put a minus 1 or a plus 1. It's not going to matter there. Okay, that's correct. Okay, I plus 1 and I minus 1 are the same. It all depends upon what value you start with. I could start with different numbers here and get different things. I just have to make it so that the first term is positive and it's negative. When I is equal to 1, I get negative 1 to the 0, which is plus 1. I is equal to 2, I get, 2 minus 1, that's negative 1 to the first power, it's negative. But if I plug in this case, plus 1, well, I get minus 1 squared, which is plus 1, and then minus 1 cubed, which is minus 1. So it's not unique, as I said. You can change these around to get the same, representation over here. These are definitely more of a challenge. Type 2 problems are a little bit more, well, quite a bit more complicated. And you can check what I have. These are even numbers. So as Ashley was saying, there's a few different ways of doing this. Let me just maybe put it as a summary up here. So, for example, if you want to represent an even number, you're going to take, 2 times I. If you want to represent an odd number, well, there are 2 ways of doing this. You could be 2 times I minus 1 or 2 times I plus 1. And depending on where you start in that sequence of odd numbers, you might use one or the other, or I could start out at a different location. And you also then want to represent alternating signs. So kind of a simple thing for alternating signs. Plus, minus, or minus, plus, minus, plus. So this is going to be plus, minus, plus, minus. So you do negative 1, and you could do it to the, if you wanted to the I power, but then I would have to start out at 0. So you'd have to have I beginning at 0, negative 1 to the 0. Or you could also write it as negative 1 to the I plus 1. And then I starts out, in this case, from 1. 1 plus 1 will give me 2. Negative 1 squared gives me positive. And the next one becomes negative. So there's a couple of different ways of writing that alternating series, and where you start is critical. You just can't put 1. You have to test it out. So I'm starting at 1, plug in 1 for I, and do I start out correctly? And then after that, it'll just go back and forth, plus and minus, plus and minus. Now, if you wanted to start out minus, plus, that's a little bit different over here. And then you can start with minus 1 to the I, and here I starts from 1. Negative 1 to the first is negative. Negative 1 squared is positive. Negative 1 cubed is negative, etc. Or you could actually start out by, minus 1. Start out to the, if you want to the I plus 1. But here I starts out not at 1, but at 0. And you can kind of see where you can get. You have to actually put it in for the first few terms to make sure it's correct. It's not unique. You just don't choose one. When even, you pretty much always choose that. For odd, it's one of those that you'll be picking. Okay, so that's kind of, if you want, from experience, things that you typically might see and or use for these summation notations. Okay.